Hello everyone. Now in this video we are going to discuss question number 13 of GATE DA 25 exam, and this question is based on linear algebra. Simple question for 1 mark here, right? Now let's read the question carefully. The sum of the elements in each row of A belong to R n cross n is basically 1 here. So A is a square matrix of order n here, and what's given to us, summation of all the elements in each row is basically equals to 1. Okay, what does this mean? So if I say summation of A I J, so here what we are saying, we are keeping the I common, we are varying the j, so j is equals to 1 to n here, that is nothing but equals to a what here, that is 1, right? Can we say like this? Because summation of all the elements in each row of this matrix A is basically equals to 1, so I will be same here. So here we are talking about ith row. For ith row, j will vary and the summation will be equals to 1. This is what we can say, right? Now, if this is given to us, now here we have if b equals to a cube minus 2a square plus a, which one of the following statement is are correct here? For x belongs to R and here, that is what we need to find out. Okay. So the given statement is this one and this expression. We have two given things. Now what do you understand by this particular statement? That is the key here. The sum of the element in each row of A belongs to Rn cross n is basically 1. What we can infer from this particular thing here. Now this means what? It means that the eigenvalues of this matrix A, one of the eigenvalues of matrix A is basically lambda equals to 1 here. This is what we can say. The eigenvalue of this particular matrix A is basically lambda equals to 1 here. Can we prove that? Let's see. Now let's consider a vector nu. Let's see, for example, 1 1 1 till 1 here. This is a column vector having all the elements 1 here. We are considering let nu equals to like this. Now what about A into nu? Okay, what about A into nu for ith row? So we are discussing about one particular row here. What we can say about this A into nu for ith row here? If we consider this particular product here, A into a nu, how the ith element of this particular product is going to get calculated, right? So we are talking about that particular row. How the product will happen? That ith row into all the elements of this particular column here, nu, right? Now, can we say that this is equivalent to what? That is basically what? Summation of Aij, Aij into nu j, where j varies from 1 to n. Can we write this as like this? Yes, obviously. What about this nu j? That is basically equivalent to 1 here. So that is basically, it is equals to summation of j varies from 1 to n a of I j here. This is what we are going to get for ith row here. And that is nothing but equals to what we can write down. So here this is basically equals to 1. This is given to us, right? This is equals to 1. This equals to 1. It means what? A into nu equals to 1 here, right? Now, what we can infer from this particular thing here? Now here 1 is basically what we can say a vector having all the elements 1 here, that is basically a nu. So A nu into this nu, right? Now what we can conclude from this particular thing? If you compare with the standard expression A nu into a lambda nu here, where lambda is the eigenvalues, if you compare this expression with this standard one, can we say lambda equals to 1 here? Yes, obviously. So this is what we can say about the eigenvalues lambda equals to 1 here. Okay, very important point to note. So in short, you just remember the sum of the element in each row of the matrix A is basically 1. It means what? Eigenvalue is 1 here. So you have to add this point into your notes. This is how you have to prepare the notes like this from the previous year question. So whenever you come across this statement, or they can ask the statement in any format. Okay. So you have to remember it means what? Eigenvalue is equals to 1. You have to write down this statement into your notes. Okay. This statement, and in after that put comma, it means that eigenvalue equals to 1. That's it. You don't need to approve all these things. Okay. So this question was asked for 1 mark, and if you know that this statement means eigenvalue equals to 1, you can easily solve this question. Okay. So this is what we can say from this given information. Now next is expression B here. Okay. B we have now B equals to A cube minus 2A square plus A, right? So what's the eigenvalue of B here? We know the eigenvalue of A, that is lambda equals to 1 here. So if we have a polynomial in L, if we have a polynomial in A and A, right? Let's see for example B here, then eigenvalue of this B will be what? B, simply we have to replace A with the eigenvalue of that matrix lambda here. It means what? The eigenvalue of this B will be what? Simply put eigenvalues here, lambda cube minus 2 lambda square plus lambda. So lambda cube is basically 1 cube minus 2 into 1 plus 1. That is nothing but what? 0 here. So we got the eigenvalues of matrix B is basically 0 here. So lambda A is equals to 1, lambda B equals to 0. This is what we can say from the given two things here, right? Now we have this information, okay? So whenever you come across this type of expression, try to simplify this or find out the eigenvalues. Almost 90% of the time, this expression can be solved based on the eigenvalues here. Or if you simplify this, then you can apply the concept of identity matrix here. So whenever you get this type of expression, always try to think about the eigenvalues or identity matrix like that. Or can we simplify this to get something? Okay. These are three things you have to think first whenever you come across this expression. Can we simplify this? After simplification, can we apply the concept of identity matrix here? Because if you simplify here, what you are going to get A into A square minus 2A plus 1, that is nothing but A into A minus 1, that is I whole square. We can say like this. Okay. So here we don't require to simplify because we just interested in eigenvalues here. But in some cases, if expression is given to you, you can simplify. And in that case, you can come across this identity matrix here. Okay. Very important point here. Either you can simplify or you can find out the eigenvalues. And after that, you can try to solve the question here. Okay. Now, let's come back to this question. So here we have eigenvalues of matrix A is basically 1 and matrix B is basically 0 here. Now, the option is equation Bx equals to 0 has no solution, exactly two solution, infinite many solution, and has a unique solution. Now we have discussed about in system of linear algebra, Bx equals to 0 means what? It is a homogeneous linear equation here, right? And if B is a invertible matrix, if B is invertible, it means what? Determinant of B is not equals to 1. It means what? It means what? It has a unique solution here, right? If B is invertible, but B is not invertible, it means what? Determinant of B is equals to 0. In that case, what we can say? B is having infinite solution here, infinite many solution here. Okay. So please do watch a video based on the system of linear equation. In that I have discussed this thing. Now this question is based on the understanding of this statement on eigenvalues, property of eigenvalues. This is basically property of eigenvalues and the system of linear equation here. Okay. Now what we can find out? Can we find out the determinant of matrix B here? Because then only we can say which one option is correct. Now, if you see here, eigenvalue is basically 0. One of the eigenvalue is basically 0 here. It means what? determinant of a matrix A, which is nothing but product of eigenvalues, product of eigenvalue. This is what we say here. But if one of the eigenvalue is 0 here, then the product will be 0. It means what? Determinant of matrix B is basically 0. It means what? It is a non-invertible matrix, right? It means what? It has infinite many solution here. So option C is correct. The equation Bx equals to 0 has infinite many solution. Okay. Now this question was asked for 1 mark here. I hope you understand the concept what we have discussed. If you know this particular thing that it means lambda equals to 1, you can solve this question in less than 1 minute. Simply put the value of lambda in this case, you will get b equals to 0, and we know that determinant of b will be 0. It means what? It has an infinite many solution. So less than 1 minute you can solve this question if you practice enough. Okay. I hope you understand the video solution of this particular question. Thank you.